In this video, I'd like to demonstrate some of the advanced features of the EWSS pulse table. In this case, I've already loaded a scenario. We have a receiver platform and an emitter platform. I'm going to create a new emitter on the emitter platform. What I want this emitter to do is I want it to be a 4-bar raster scan where each bar of the scan has a different frequency. So I'll go into the mode and I will select raster scan, and we'll make this a unidirectional raster scan with a 60-degree wide scan pattern, and we'll set the scan rate to be 10 Hertz. Now a 10 Hertz scan rate means that the entire scan will complete in 100 milliseconds. If the entire scan completes in 100 milliseconds and there's 4 bars to the scan, each bar takes only 25 milliseconds. I'm also going to turn on this emitter, and I also want it to track our target platform, and then I can go ahead and play the scenario. And you can see that the emitter has come on, and it appears though as if the scan isn't moving, but that just happens to be a coincidence of the refresh rate being the same as the scan rate. Clearly we can see that the scan pattern is actually occurring, and you can see these smaller bars on the outskirts of the scan, bar 1, 2, 3, and 4, all occurring. So the scan pattern is working properly. Now we'll go into the pulse table, and in the pulse table, since we have 4 bars of a raster scan, we want 4 rows of the pulse table. And each row of the pulse table will have to equal 25 milliseconds. So in order to do that, I'm going to help myself here with adding a duration to the end of the end of each row. So now I can see that there is 1 millisecond for each of these rows. I want that to be 25 milliseconds. To do that, I can use the pulse wizard, which by just simply right-clicking on the header of the column, I can open the pulse table wizard, and I can select, you can see 4 pulses are selected. The parameter I'm modulating is PRI, and I can make this a linear modulation type, just meaning that I will apply the same value to all the elements in the table for PRI. I'm going to change this to 250, and you notice that it changes the PRI. I can also do this for count. Same thing. I want to make the base pulse count to be 100 for each one, which should give us 25 milliseconds or 25,000 microseconds per row of the table. I would also like to change the graph to be a frequency versus time graph, because the whole purpose of this is to adjust the frequency for each one of these legs of the raster scan. Again, when I go to the pulse wizard, I can select only as many of the elements as I want. I could manually enter these here, but again, I'm going to right click, go to the pulse table wizard, and in this case set a ramp up from a baseline frequency of 5,000, and I can use a percentage if I like, such as 1%, and that would give me a 5,000 to 5,050 ramp up applied evenly across all the elements of the pulse table. Or I can just enter the value 10 megahertz like so, and it'll go 5,000 to 5,010. Now you can see that each element of the pulse table is at a different frequency, and we have the correct amount of time for each bar of the scan. So let's go to the simulation view where we have a receiver, and we can see this in the frequency domain. and we can see four different frequencies showing up, but they're coming in, the scan rate is so high that they all appear to be simultaneous. However, if I slow them down, now you can see that there are four separate legs occurring at different times. And if I slow it down still further, it makes it very clear. 1, 2, 3, 4. Four different frequencies, one for each bar of the raster scan. And that concludes the advanced features of the EWSS pulse table.